Now, uh, see, before giving a statement for first law of thermodynamics, let us first discuss Joules experiment. So Joules experiment states that, see, look at the experimental setup here. So this is an adiabatic vessel. It is completely insulated. Inside you have water, and this there is a paddle is inserted here, and this paddle is connected to a pulley, and at the end of this pulley you have the mass. So if this weight falls down, that means this fan will rotate. Okay, it is arranged in such a way that, so when this mass falls down, this paddle will rotate, and when paddle will rotate, it means that that is a shaft work. This work is transferred into this water. Here we are taking this water as our system. Okay, so this is the experimental setup. First, what we are doing to in Joules experiment, first what he did was he just measured the temperature using a thermometer, temperature of the water, made a measurement with a thermometer. Now what? So let that be T1. This temperature is T1. Now what happens is the mass is allowed to fall. When mass is allowed to fall, the shaft rotates. By rotating the shaft, you are transferring an energy in the form of work into the system, that is water. Okay. So when you transfer energy to the system, what happens is that because of this shaft work, this water can get heated. So its temperature rises up. Okay, so you will be it is easy to calculate the work because this can be calculated as force into distance. Force means the weight of this, so that is m into g, and distance is the distance traveled by this weight. So that is f into s. This is equal to m into g into s. Again, you are using a thermometer to measure the temperature T2. Okay, now you know that when the work is transferred, so energy is transferred to the water, so its temperature rises up, so its temperature becomes T2. It is higher than T1. Okay, so and then we are removing that insulation at the bottom. Okay, when you remove this insulation, what happens is that heat will be transferred outside. Okay, heat is transferred outside. See, we will allow this till the temperature becomes T1 again. So when you measure the temperature, when the temperature becomes T1, we stop it. Okay. So then you can calculate the heat transferred by using this expression. That is mass of the fluid, that is the water inside, into Cp, that is its specific heat of water, into T2 minus T1. So you can calculate the work. So what he found was this W was equal to Q. This work was equal to Q. This was the Joules experiment. So he was the first person to establish the equivalence of work and heat. Through his experiment, he found that this will be equal to W is equal to Q. Or you can say that is cyclic integral of delta Q is equal to J into cyclic integral of dW. We will see what is cyclic integral. So in SI units, this J is equal to 1. Okay. Uh, Cyclic integral means, see, this is for a cyclic process. That means for a state starts from 1 and finally comes back to it, state 1 itself. So this is called a cyclic process. Okay, and cyclic process is represented by this symbol. Okay, cyclic process. So cyclic process, this means total heat transfer that occurred in this cyclic process, and this is the total work that is that occurs in this uh, cyclic process. Okay, so J is equal to 1 in SI unit. So this is what he observed. That is cyclic integral of heat transfer. In this case, cyclic integral of heat transfer, this includes heat added and heat rejected, all kinds of heat transfer, and also work means all kinds of work happen that uh, in the cyclic process.